Sawadee Kab and hello! Welcome back everybody. It's video number 2, day 2 of our video learning. Today we're going to be learning about math. It'll be our first lesson in mathematics, so you'll need this book. One other thing that you'll need is your paper as well as a pencil. First, I promised you guys I would show you the new changes to the school. So let's take a look around the school at what has changed. Let's go. Let me show you how to reach me in my office. I am always willing and available to answer your questions. Actually, I hope that you guys come see me when you need help and it's not during class. I'll show you exactly where I'll be.
Hold me down before I scream.
So as I said, we've made some changes around the school. I'm walking down the stairs right now. That looks familiar, right? Look what they did. But that's not it. Check it out. This is where the first grade is going to be now. So here's the basketball court. And now we have new rooms. Looks a lot like upstairs. Down here's the main hall where we'll have assemblies. One other thing that we're doing while you guys are gone is we're gonna make the walls on the football field a little taller. So they're adding in these giant nets. So it's pretty loud here right now. That's because they're working really hard to finish it before you get here. So when you guys get back, there's gonna be a crazy new building. Okay guys, our first topic, just like I explained in video 1, we have 8. Our first one is numbers. That's right, we're gonna learn about numbers in this class. Who'd have thought? But why? Why do we learn about numbers? Well, sometimes you're only given numbers. Sometimes you can't simply hold something in your hands just to see if it's bigger or smaller than something else, right? Like, what if I said, this dice is smaller than this dice? Well, we can clearly see that one is bigger than the other, so we know that. But what if we were given numbers, like the area or the perimeter, the outsides of each of those shapes, without actually holding the physical item? Well, we're given numbers for that very reason, because sometimes the objects are really small. Sometimes the objects are decent size. Sometimes they're giant. Some things are even as big as planets.
Wow.
And you can't actually hold them. All you know is a number given to them, a measurement. We can't simply go up to the moon and figure out how big it is with a measuring tape. But we can estimate its size, and we're given a number. What if I said that the Earth was that big? You can't even see it, right? Or can you? Sometimes we're just given numbers for the sizes of planets. What if I asked you, what planet is bigger? Well, you can't simply look up into the sky and be like, oh, that one's bigger, because you don't know for sure. But what scientists have done and we'll learn about this quite a bit in science, is they've given us an estimate of the diameter of certain planets. And they're asking us, which one is bigger? Right here, we're given two planets, Jupiter and Saturn, and then our sun, which is not a planet, it's a star, but it wants to know which of these three is bigger. And it gave us a diameter, and a diameter is simply from one side of the circle to the other side of the circle. The sun's diameter is 1,395 and 822 kilometers in diameter. So that's this number right here. Saturn is 116,000. So the book says that our sun is 1,391,400 kilometers. Saturn is 116,464 kilometers. And that's in diameter, remember, from this side to this side. Jupiter is 139,822 kilometers wide. So which one is the biggest? Let's come back to this example. Okay guys, let's try to remember back to the beginning of grade 3. I think I can remember that. But at the beginning of grade 3, you guys were told that when you add 10,000 10 different times, so 10,000 times 10, you get 100,000. And all you're doing is you're taking 10,000 and you're multiplying it by 10 times. All you're doing is taking that 10,000 and adding one more zero on it to make it 100,000. We're gonna get to this in a minute, but what do you think would happen if we added 10 of these together? How many zeros do you think there would be? Probably one more, right? That would make it 1,000,000. What do you think would happen if we took 100,000 and divided it by 10? You'd end up back at 10,000. If you do one thing in math, you can reverse it by doing something else. Like if you add 3 plus 3 equals 6, you can do 6 minus 3 equals 3. Likewise, you can do 2 times 4 equals 8, or you can do 8 divided by 4 equals 2. But don't worry about that yet, we'll get there soon. Guys, so what we're going to do is we're going to be given 10,000 coins, we're going to be given 1,000 coins, 100 coins, 10s coins, and 1s coins. And from these coins, we're gonna add them all together to see what number we get. You guys have seen this before, so it shouldn't be too difficult, but I will go through slow to make sure that you guys remember, okay? So, we have our 10,000s column. This 10,000s column, can you tell me how many 10,000s we have? Let's count. So we have 1, 2, 3, 4, 5. So what I'm gonna do is just put a big 5 right there. So, just like that, if we look at the thousands, how many thousands are there? It looks like 1, 2, 3. So I'm gonna put a giant 3. Now, if you guys can remember where we put our commas, this is where you put your commas. You start from the right and go 3 digits and then put a comma. Okay? Now let's look at our hundreds. Our hundreds. How many hundreds do we have? 4. Let's put a giant 4 there. Okay? How many tens do we have? How many tens do we have? Well, it looks like 1, 2, 3, 4, 5, 6. Boom, giant 6. Lastly, our little guys, how many ones do we have? 2. Okay, so now we have a number. That number is pretty big, but let's say it together. So we know we have at least 1,000, but we also have these tens of thousands and thousands. So the way I do it is each comma, you basically say what number's in between those commas. So let's say here's a comma here and a comma here. What's this number? Yep, 53. So we have 53 and then 3 digits after. So it's 53 and 462. So look at this first, 53, and we know that there's 1, 2, 3 digits after it. So we know that that's 1,000. 1, 2, and 3, it's 1,000. So we have 53 thousands and we have 462. All right? So we have 5 10,000s. 5 times 10 is 50. We have 3 1,000s, 3,000, so 53,000. This comma, when you see this comma, you say the word and, okay? So 53,000 and then you just look at this number. What's that number? 462. 53,000, right? 53,000 and 462. All right? So, pretty simple, right? Let's break that down a little bit further, okay? We'll start with the easy ones first. So, our 2 in 53,462. What is our 2? What place value? What place is that in? Is that in our tens place?
No.
No. Is that in our 10,000s place?
No.
No. Our 2, if you got rid of all the other numbers, it would just be the ones place, right? And we know that from right here. We have 2 ones. So next, we'll look at the 6, just because it's easy, right? What place is the 6 in? So, what times 6? Tens. Our 6 is in our tens place. Next, remember we can go from right to left. You can pretend that these numbers don't exist for the second, all right? So, our 4. That one's pretty easy too, right? What place is our number 4 in? Well, if you said hundreds, bing, 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 you are correct. Hundreds. By the way, I want you guys to get used to this chart right here. We're gonna be dealing with this all year, okay? Because we don't just stop at big numbers. We also work with really, really tiny numbers. But I'll explain that later. Don't worry about that. That's in semester number 2. All right? Let's look at the next one. The next one is the number 3. So we have 1, 2, 3, 4 places over. What place is the 3 in? Well, if you said thousands, then you'd be correct. Okay? And then lastly, we have our big number. And right now, we're only dealing with tens of thousands. What do you think the 5 place value is? 10,000. So when we look at this, when we're all finished, it's very easy to understand that there are 5 10,000s, there are 3 1,000s, 4 hundreds, 6 tens, and 2 ones. So together that makes 53,462. Pretty easy, right? So this is what place each number is in an actual number. But we also need to figure out what the value of each of them are. What would they be if they were all alone? All right, guys, we're out of time for today, so we're gonna take a look at that tomorrow in video number 3. See you tomorrow and have a wonderful day.